This is an example of an object moving in 3D. So in principle, when an object is moving in 3D, vector position has a three components along x, y, z. So in general, the vector position has a coordinate along the x-axis plus a coordinate along the y-axis plus a coordinate along the z-axis. And then the vector velocity is the derivative of the rate of or the rate of change of the vector position, and the acceleration is the rate of change of vector velocity, and it's also the second derivative of the vector position. So in this example, we have a point-like object that is traveling in space and has the following coordinate, x, y, and z. And the first question is, what are the unit or dimensions of the parameters a, b, tau, and omega? Now, it's clear that if xt is equal to a exponential minus t tau, so a must be in meters because this has no unit, and x must be its a position coordinate, so it has be meters, so the dimension or the unit of a is meters. We know also that t over tau should be dimensionless, so which means that the dimension of tau must be a second. The same thing, we know that b sine omega t, this has no dimension, and this y, or since yt is equal b sine omega t, this means that the dimension of b must be in meters. So a, b are in meters, and tau is in second. And now, what about omega? So we know that sine omega t, so what is inside should be in radians. So the unit of omega t must be in radian. And since this one is in second, this means that omega is, or the unit of omega is radians per second. This is question A. Question B, determine the projection of the trajectory of point M on the XYZ plane. Now, so what is the question? Question is, I want to projection of the trajectory of this object on the plane YZ. So I know that, so how do we do the projection is vector, I will call it YZ, and this vector is just the coordinate y, t, j plus z, t, k. Okay, so what is yt? Yt is equal to b sine omega t j plus b cosine omega t k. This is what is given here. Okay, so this is the vector projection along the y-axis and the z-axis. Now let's look at the distance or the vector, the magnitude of this vector. Well, the magnitude of this vector is the following. The magnitude of this vector is the following, is the square root of y square t plus z square t, okay, which you can easily see it's equal to b, okay, because this is b square sine square omega t, b square cosine square omega t. What does this mean? This means, in fact, this object, if I look at y and z-axis, this object, whatever the time, this object is, this is the b, okay, this is b, this object is just doing a circle that has radius b at any time. So at any time, this object has a projection of a circle along the the YZ projection. Okay, so the last question is what are the coordinate? Yeah, question C, determine the coordinate of the velocity vector, and then question D, the coordinate of the acceleration vector. Well, the velocity vector is just the derivative dx over dt I plus dy over dt j plus dz over dt k. Now, what is xt? Xt is a exponential minus t over tau. Yt is b sine omega t, and zt is equal to b cosine omega t. So this will easily give me the derivative of x with respect to I is, it will be minus a over tau exponential minus t over tau. Okay, and then the derivative of y will give me b omega cosine omega t. Okay, and then the derivative of z will be minus b omega sine omega t. Those are the component of the velocity. And if we go to the component of the acceleration, which are the second derivative of the position or the first derivative of the velocity, again we give an a over tau square exponential minus t over tau, and here it becomes minus b but omega squared sine omega t, and then it also becomes minus b omega squared, but this time cosine omega t. So those are the components of the velocity and the acceleration.